Hello students, before we get into today's class, let us do a quick recap of what we learnt in last class. We started learning about trigonometric functions and we extended all the trigonometric ratios to all angles in radian measure. Then we derived a basic identity in trigonometry, cos square x plus sin square x equals to 1. Then we learnt about quadrant angles, which is integral multiple of pi by 2. Then we derived the cos and sin values for all quadrant angles, and then we started analyzing these values and we came to a conclusion that the sine and the cosine value remain same. They do not undergo any change in integral multiple of 2 pi. When x undergoes integral multiple of 2 pi, the sine and the cosine values remain same. There won't be any change. And also we observed that the sine value becomes 0 when x is the integral multiple of pi, and the cos value becomes 0 when x is a odd integral multiple of pi by 2. Then what we learnt, we defined the other trigonometric functions in terms of sine and cos. Cosec is the reciprocal of sine and secant is the reciprocal of cos and cot is the reciprocal of tan. Then from the first identity we derived the remaining two basic identities, 1 plus tan square x equal to secant square x and 1 plus cot square x is equals to cosec square x. And then we framed a table of all the standard angles and its trigonometric ratios, sine, cos and tan, from 0 to 2 pi, right? 0, pi by 6, pi by 4, pi by 3, pi by 2, pi, 3 pi by 2 and 2 pi. We have tabulated all the values. So with this we completed last class. Now in today's class we are going to learn about the sign of trigonometric functions, how the sign is going to vary when the angle varies in its sign. That's what we are going to learn in today's class. Now let us consider the same unit circle, and so far we have analyzed with the point P with coordinates a comma b, right, and this is x radian. Now assume a point P such a way this is minus x radian, that the angle is minus x radian and the coordinates of Q are a comma minus b. Now what will happen to cos minus x and sin minus x? Before getting into minus x, let us find what is cos x and sin x, right? Now if the coordinates of P are a comma b, then what is the measurement of this? This will be b and this will be a, right? If this is going to be a comma minus b, this remains a and this is going to be minus b, right? Now what are we going to do now? Now we are going to find the cos x, sin x in the same way cos minus x and sin minus x. Now what is cos x? Cos x will be, we know cos x is adjacent side by hypotenuse. We know this is a unit circle, so this is going to be 1. So cos x is a by 1, which is a, and sin x is b by 1, which is b. This we learnt in the last class. The same way we are going to derive what is cos minus x. Cos minus x is going to be, again this is your angle, so this is your adjacent side hypotenuse and this is your opposite side. So cos x is going to be a by 1, which is remain a, and sin of minus x equals to is going to be minus b by 1, which is minus b. So if you analyze these two, what you infer? Cos of minus x is same as cos x, but sin of minus x is nothing but minus sin x. Yes, because sin x is b, sin of minus x is minus b. So cos of minus x is cos x, sin of minus x is minus sin x. So again the next thing which you should remember is these two. If the cos value remains the same, if the angle changes in its sign, but the sine value becomes the negative of its value when the angle changes in its sign. Cos of minus x is cos x, sine of minus x is minus sine x. Now let us analyze the signs of the trigonometric ratios. This we learnt in our previous classes itself. We know this is first quadrant, second quadrant, third quadrant and fourth quadrant. In the first quadrant, both x and y values will be positive. In the second quadrant, x value will be negative, y value will be positive. In the third quadrant, both will be negative, and in the fourth quadrant, x value will be positive and y value will be negative. This we know already, right? So based on this, now we are going to define the sign of our trigonometric ratios. How can we do this? So far we have done many things. So based on these, we can come to a conclusion saying that the cos value depends on the x value of the point, right? Sine value depends on the y coordinate of the point. So sin x we got b and cos x we got a. So cos value depends on x coordinate and sine value depends on y coordinate. So with the same argument, now we are going to define the sine. So first let us take cos function and we will see where and all it will be positive and where and all it will be negative. So cos value, as we discussed now, it depends on the x coordinate. So from 0 to pi by 2, this is pi by 2, right? So from 0 to pi by 2, cos is positive, and from pi by 2 to pi, this is pi by 2 to pi, it is negative. Then from pi to 3 pi by 2, again it is negative. This is 3 pi by 2. From 3 pi by 2 to 2 pi, it is positive. Yes, so what are all the signs of cos now? Cos value, what happens from 0 to pi by 2? 0 less than x less than pi by 2, it is positive. And from pi by 2 to pi until 3 pi by 2, it is negative. So pi by 2 less than x less than 3 pi by 2, it is negative, right? And from 3 pi by 2 to 2 pi, it is positive. 3 pi by 2 to 2 pi, it is positive. Hope you understood. Similarly, now let us define the sign of sine function. Sine function depends on y coordinate. If you check out y coordinate, from 0 to pi by 2 it is positive. Then again from pi by 2 to pi also positive. So 0 to pi, sine function 0 to pi, it is positive. Then pi to 3 pi by 2, it is negative. So pi to 3 pi by 2, it is negative. We are bothered about y coordinate now. From 3 pi by 2 to 2 pi, also it is negative. 3 pi by 2 to 2 pi is also, it is negative, right? So these two we can combine and write pi to 2 pi, it is negative, right? So cos value depends on the x coordinate. So based on the x coordinate sign, we have assigned the sign for the cos function. And similarly for the sine function, we have assigned the sign based on the y coordinate. And this is the basic idea which we know already, how the values will be in the first, second, third and fourth quadrant. Now we have we have connected quadrant with the radian measure angle. So we told first quadrant will be from 0 to pi by 2, second quadrant will be pi by 2 to pi, third quadrant will be pi to 3 pi by 2 and the fourth quadrant will be 3 pi by 2 to 2 pi, right? Hope you understood. So likewise we can assign the sign of the other trigonometric ratios as well, so that we can find out in which place that particular value will be positive and which place the particular value will be negative based on the angle, right? So whenever we have an angle, first we will check out the position of the angle, in which quadrant it lies, first, second, third or fourth. So based on the position of the angle, we can decide the sign of the trigonometric function, right? Now listen, this is what we did. First quadrant, second quadrant, third quadrant and fourth quadrant. I have listed out all the trigonometric ratios. This is plus plus, this is minus plus, minus minus, plus minus. So x value depends, cos value depends on the x coordinate. So here x coordinate is plus. So in this quadrant cos value will become positive. In this quadrant cos value will become negative. In this quadrant cos value will become negative. In this quadrant cos value will become positive. Now come back to sine. Sine depends on y coordinate, right? Sine depends on y coordinate. Now if you check the y coordinate, here it is positive. And in the second quadrant y coordinate is positive, so it will become positive. And here y coordinate is negative, so this will become negative, and here also negative. Alright, now come back to tan. Tan is the ratio of sine and cos. Tan theta is sine by cos. If both are positive, tan will also be positive. If one negative and one positive, when you take the ratio, it will be negative. Both are negative, also you will get positive. When you take the fraction, both negative will get cancelled. Here it will become negative. So this how we can assign the sign of the trigonometric ratio. So when you know the cos, sine and tan, we can very well assign the sign of its reciprocals. The reciprocals will behave in the same way. So if cos is positive, secant will also be positive here. Sine is positive, cosec will also be positive here. If tan is positive, cot will also be positive here. So every trigonometric, the ratios, the reciprocals will also behave in the same way. Right. So if you analyze this, all the three trigonometric ratios are positive in the first quadrant. And if you see, only sine is positive here. Here only tan is positive. Here only cos is positive. So how will you remember all these? So we used to have a clue which is called as all silver tea cups. We will remember in this way. All silver tea cups. You have to write from the first quadrant. All silver tea cups. What does it mean? In the first quadrant, all the trigonometric ratios will be positive. All. In the second quadrant, silver. Yes. Yes means sine and its reciprocal alone will be positive. Sine and its reciprocal alone will be positive. In the third quadrant, tea. Tan and its reciprocal alone positive. In the fourth quadrant, C, only cos and its reciprocal will be positive. Remaining ratios will be negative. So this how you can remember the sign of the trigonometric functions. So what it is? All silver tea cups. All the trigonometric ratios are positive. Here only sine and its reciprocal. Here only tan and its reciprocal. Here cos and its reciprocal. This denotes the positivity, right? All silver tea cups. Don't forget. And also you should know first quadrant is from 0 to pi by 2. This is pi by 2 to pi. This is till 3 pi by 2 and this is 2 pi. You should know the radian measure as well, right? Hope you understood this. Let us move on to the next topic. Now let us learn the domain and range of the various trigonometric functions. First, if you take sine function, its domain is going to be the entire real number system and range is the closed interval minus 1 comma 1. How we got this? Because the sine and the cosine functions are defined on a unit circle, right? They are defined on a unit circle. So if you analyze the unit circles, the angle can be any radian. Right, the angle can be any radian, therefore it can be any of the real number system. But the values sin x we got as a. Yes. See, this angle x can be any radian, which can be any one value among the real number system, because this entire is going to be 360 degree. But when you see the values, the range of sine function or cosine function, it can be 1 among minus 1 to plus 1. Minus 1 to plus 1, because we have considered on a unit circle and the values are based on the points which we are taking, which we are going to take on the circumference of the circle, and the radius is going to be 1 unit. Therefore, the value can lie between -1 and 1 only. Therefore, the range of sine and the cosine function is the closed interval -1, 1, whereas the domain is the entire real number system, right? The same way, if you see cosec x is the reciprocal of sine. So when sine comes in the denominator, immediately we will say it should not be equal to 0. When the sine value will become 0? During the integral multiple of pi. So we have mentioned that it's set of all x such that x belongs to R, where x is not equal to n pi. If x is equal to n pi, the sine value will become 0. So the cosec function will not be defined on that particular value. So the domain is this. What will be the range again? The range is, it can be greater than or equal to 1 or less than or equal to -1, which means it cannot take up the value 0 there, right? It cannot take up the value 0. Similarly, secant x is 1 by cos x. 1 by cos x, again we will state that when cos value becomes 0 during the odd integral multiple of pi by 2. Therefore, x should not be equal to that, but the remaining real number system. Here the range will be the same as cosec. It cannot take up the value 0. There is no possibility for the secant to become 0. Then tan x is, again the domain is going to be, because tan x is sine by cos, we are going to get cos in our denominator. Therefore, it should not be equal to 2n plus 1 pi by 2. But the range can be any real number. And cot x is, denominator we are going to get cos x, therefore, denominator is sin x, therefore it should not be equal to n pi, and the range is going to be entire real number system. So you should remember the domain and range of these trigonometric functions. Again, you can have some clues to remember. If you check out this, sine and cos have same domain and range, and cosec and secant have same range. Tan and cot have same range, and even the domain are also same, except for some minute points which depends on the denominator. Cosec x is the reciprocal of sine, so you should remember what is the condition for the sine to become 0. That alone you have to add it. Otherwise, the domain of cosec and secant are same. Similarly, tan and cot and sine and cos. In such a way, you can remember the domain and range of all these trigonometric functions, right? Let us move on to exercise 3.2. First question, find the values of other 5 trigonometric functions. Cos x equals to -1 by 2 and x lies in the third quadrant. They have given only one trigonometric value. Using this, you need to find out the remaining other 5 trigonometric functions. So first, when you know cos, immediately we can find what is secant, because secant is the reciprocal of cos, right? So secant x will be 1 by cos x, so which is equals to 1 by -1 by 2, so it will become -2. So secant x is -2. Then we need to find the remaining trigonometric ratios, and we know the relation between cos and sine, right? What is that identity? Cos square x plus sine square x equals to 1. So now cos x is -1 by 2. So cos square x will be -1 by 2 the whole square plus sine square x equals to 1. So this is 1 by 4 plus sine square x equals to 1. So sine square x equals to 1 minus 1 by 4. If you take LCM, it will become 4 minus 1, which is 3 by 4. So sin x is square root of 3 by 4, which is equals to plus or minus root 3 by 2, right? Plus or minus root 3 by 2. Now we have to assign the sign of sin x. So for that case only they have given you in the question that x lies in the third quadrant. X lies in the third quadrant. Which is your third quadrant? 1, 2. This is your third quadrant. And I told you all silver tea cups. So in the third quadrant only tan and its reciprocal is positive. Remaining all other trigonometric ratios are negative. Therefore sin should be negative in the third quadrant. Therefore sin x is equals to minus root 3 by 2. since x lies in third quadrant. Right, now we have found what is secant x and we found what is sin x. Now immediately after finding sin, we can find its reciprocal, which is cosec x. Cosec x is 1 by sin x, which is equals to minus 1 by root 3 by 2. This minus only I have written here. So this will become minus 2 by root 3. So we found what is cosec x. Next we need to find what is tan x. Tan x is sin x by cos x. What is sin x value? Minus root 3 by 2, and cos x value, which is given in the question, as minus 1 by 2. So minus minus will get cancelled. So root 3 by 2 into 2 by 1, 2 will get cancelled. So tan x is root 3. Now once you know what is tan x, we can find cot x. Cot x is 1 by tan x, which is equals to 1 by root 3. Right? Thus we found all the remaining 5 trigonometric ratios. Right? This is very easy. You can proceed with the problem. Only thing is you have to analyze the sign of the given trigonometric function using this. All silver teacups. Don't forget this. Then you can easily solve the problem. Hope you understood. Let us move on to the next question. Let me solve one more problem of the same kind, and I am going to leave the remaining problems in the exercise. You need to solve it. See, sin x equals to 3 by 5 and x lies in the second quadrant. So immediately when you know sin, its reciprocal you can find out. The reciprocal of sin is cosec x. So 1 by 3 by 5, which is 5 by 3. We found one trigonometric ratio. Then since you know sin x, use the identity sin square x plus cos square x equals to 1. Substitute the value and you can find what is cos square x. We obtained the value as plus or minus 4 by 5. Now here is a stage where we need to decide the sign of the cos function. In that case only they have given x lies in the second quadrant. So all silver teacups. So in the second quadrant only sin and its reciprocal is positive. So cos will become negative. Therefore cos x is minus 4 by 5. So once you know cos x, you can find its reciprocal. Reciprocal of cos x is secant x, which is 1 by cos x. So you will get minus 5 by 4. Then you can find either tan x or cot x. So I found here cot x. Cot x is cos x divided by sin x. So you know the values for both cos x and sin x. Substitute and find the value. Therefore tan x will become minus 3 by 4. Reciprocal of cot x. Thus we found all the remaining 5 trigonometric ratios. So in both the problems what we solved, initially we know the value for sin and cos. So we went with cos square x plus sin square x equals to 1. Suppose if you see the third, fourth and the fifth question, they have given you the values for cot x, secant x and tan x. So wherever is needed, you should go with the necessary identity. You know the 3 basic identities, right? Sin square x plus cos square x equals to 1. Then 1 plus tan square x is equals to secant square x, and 1 plus cot square x is equals to cosec square x. So accordingly you have to use that identity and you have to find the appropriate trigonometric ratios. Yes, hope you can do it. Let us move on to the next question now. Now let us solve the next type of problems. Find the values of the trigonometric functions. First one is sin 765, and here only we are going to use the inference which we obtained. The value of sin and the cos will repeat after an interval of 2 pi or 360. We have learnt, right? For any integral multiple of 2x, the value 2 pi. For any integral multiple of 2 pi, the sin and the cos values do not change. Similarly, for tan function, it will repeat after an interval of pi or 180. You should remember, for sin and cos it's 2 pi and for tan it is pi. Using this result only we are going to solve our problems. The main idea behind solving such a kind of problems are, we try to express the given angle as a multiple of 2 pi in case of sin and cos and pi in case of tan and cot, plus some standard angle which we know the sin, cos and tan values. I repeat, whatever question is given, what you should do is you try to express it as a combination of multiple of 2 pi for sine and cos plus some standard angle, and multiple of pi for tan plus some standard angle. அப்படி எழுதுனா we can use this result and we can go with only the standard angle value so that you can get the answer, right? If you see the first example, sine 765 degree. Now sine 765 degree, how can we write? Divide 765 by 360. If we divide 765 by 360, we will get 2 times 360 plus remainder will be 45, right? So 765 can be written as 2 times 360 plus 45. Now 45 is a standard angle only, so you can write as such. Now sine 2 times 2 pi, right? 2 times 2 pi plus 45. So by the conclusion, by the result, we have sine of 2n pi plus x is nothing but sin x. Hope you remember. What is that result? Sine of 2n pi plus x is equals to sin x only, right? We know this result, that's what it says. Therefore 2 times 2 pi, 2 times 2 pi plus 45 will give you sin 45 only. So what is sin 45? 1 by root 2. So we have arrived at the answer, right? Now let us see the next example, cosec minus 1410. If you take this example again, try to express this number as a multiple of 360 because cosec is a reciprocal of sine, therefore cosec and secant also behave in the same way as sine and cos behave. So the value will repeat after every 2 pi, interval of 2 pi. Every interval of 2 pi, the value of cosec and secant will also repeat as sine and cos, right? So try to express this 1410 as a multiple of 2 pi plus the remainder. So what happens here? If I divide 1410 by 360, I am getting 3 times 1080, and if I subtract, I am getting 330. So if I express this, how I should express? Minus 1410 plus 330 I have to write. 3 times 360 plus 330 I have to write. But 330 is not a standard angle where we cannot get our answer directly. So in such case, what you should do is, you go beyond. What are we going to do is, you add the next of the quotient. What is the next of the quotient? 4, right? So 4 times 360 you write. Anyhow the value is not going to change because the result says in every interval of 2 pi the value is not going to change. So 4 times 360, or even if you are going to write 5 times 360, the value is not going to change, right? So what are we going to do here? Cosec of minus 1410 plus 4 times 360. Why we have written 4 times 360? If we go with the usual method what we did for the previous problem, we are not getting a standard angle to get our answer directly. So what are we going to do? We are going to rewrite this minus 1410 as minus 1410 plus 4 times 360. How we got this 4 is the next number of the quotient. Yes, and why this is 360? Because we are dealing with cosec function. We know in the cosec function the value do not change after an interval of 2 pi. What is 2 pi? 2 pi is 360. Hope you understood. Now 4 times 360 is 1440. Now add these two, we got 30 degree. 30 degree is a standard angle only. Now cosec is nothing but the reciprocal of sine. If you don't directly remember what is cosec 30, you can write 1 by sine 30. Sine 30 value is 1 by 2. So if you reciprocate it, you will get 2. Yes. Now let us see another example. Cot of minus 15 pi by 4. Again, if you divide 15 by 4, what will happen? 4 3s are 12, remainder is 3. So if I want to write minus 15 pi by 4, how can I write? I can write 3 pi plus 3 pi by 4. Right? But again 3 pi by 4 is not a standard angle. So what we did here, the next number of the quotient which is 4 pi. So we are adding 4 pi with this. When you take LCM, we got pi by 4. Cot pi by 4 is nothing but pi by 4 is 45 degree. Tan 45 is 1. So cot 45 is also going to be 1. And one more thing here we should notice here is, see, this sort of method for which kind of problem you should adopt when you have a negative angle. When you have a negative angle. When you have a positive angle, it is suffice if you just split and add the standard angle. When you have a negative, you cannot split and add, because one will be in negative, one will be in positive. So obviously you have to subtract, you won't get the actual value. So to obtain this number, you have to add only. You have to add the multiple of 2 pi and multiple of pi according to the function which you got in the question. If it is going to be sine, cos or its reciprocal, you have to add the multiple of 2 pi, and if it is going to be tan and cot, you have to add the multiple of pi. So which multiple of pi you have to add, it depends on the question angle. That angle you divide and the next number of the quotient you have to add. Okay, remember in this way. Whenever you have negative angles, what you have to do, you have to add the multiple of 2 pi and multiple of pi according to the question. What is that multiple? How will you choose? By dividing the given question by 2 pi or pi according to the question given, right? Hope you understood. If it is going to be positive angle, you can directly split it into the multiples and then add the remaining, so that you will get the actual question. This way you cannot write the negative number, because if you write, one will be negative, one will be positive, so you have to subtract. If you subtract, you won't get the actual angle what is given in the question, right? So with this, let us wind up today's class. Before winding up, I wish to recall what we learned today and what are all the things you have to remember. Cos of minus x is cos x, sine of minus x is minus sine x. These two things you have to remember. Then the sign, all silver teacups. In the first quadrant, all the trigonometric ratios are positive. In the second quadrant, sine and its reciprocal. Third quadrant, tan and its reciprocal. In the fourth quadrant, cos and its reciprocal are positive. Remaining and all negative. This you have to remember. Then domain and range of the trigonometric ratios. This also you have to know. Then we have solved problems finding the remaining trigonometric ratios. Hope you can do this very well. And the last method, finding the values of the trigonometric values of the angle which is given. Here I told you, when you have positive value, try to express it as a multiple of 360 degree plus the remainder. Then by applying the result after an interval of 2 pi, the sine and the cos values will remain same. So, and even the reciprocals, cosec and secant, will behave in the same way. And for tan, after an interval of pi or 180, it will repeat. So when you have negative, you just divide by 360 and check the quotient, and the next number of the quotient you take it as a multiple and add it, so that you can apply the result and you can get the answer easily. And when you have a radian measure, these two problems are of degree measure. When you have a radian measure and if they give in fraction, again the same procedure, you can divide directly and check the next number of the quotient and then express. When you have a negative angle, when you have a positive angle, the same way you can express it as a multiple, right? So with this, let us wind up today's class and do these problems as homework and post it in the group. And if you have any doubt, just contact me. Thank you, students.